In this video I want to go over this math problem that you guys had to do for the practice test. Just kind of explain how to walk it through, and just remember to try not to get frustrated or confused. You just gotta kind of work it through like you're actually there. The biggest thing is just try to visualize what's really happening, make the numbers work for you. Don't just try to put the numbers together in some random way. Make sure it makes sense to you the way you're doing it. So let's take a look at what's happening here. We have this section of land. It's corded off into these different pieces, and each of these chunks is 200 cubic meters. Now, each of these sections has a different concentration of gold, right? No gold in these, but they're like what's called the overburden. We got to get through that anyway to get to what's underneath. And this is 1 times 10 to the negative fourth percent, and this is 2 times 10 to the negative fourth percent, right, by volume of gold. That's what these numbers represent. Right, so of this section, 0.00002% of it is gold. And it doesn't sound like a lot, but gold is worth a lot of money, so it might be worth it to dig this up, and that's what we're trying to find out. Right? So let's look at this first question. It says calculate the volume of gold in cubic meters that can be mined from the excavation of all 20 blocks. So we got to dig all this stuff up anyway to get what's underneath. And remember that these numbers are in percentages. We don't want it as percentages, we want it as an amount. So we have to change these from percentages to a straight up concentration, which means, remember what you do to get a decimal into a percentage is you multiply by 100. So to get it out of a percentage, we're going to have to divide by 100. So let me show you how that would work out. We need to look at our previous problem here. So now we're going to calculate the percent of gold. So again, looking at this problem, it says calculate the percent of gold in the total excavation. Show your work. And this one's actually a little bit easier. Than the first one. So what we have to do here is just look at the percentages that were given and then add those together. So right. So the next part is C. So looking at the total cost for excavating is 1.5 million. Basically, calculate the price that the gold must be sold for in dollars per gram in order to break even. And they give you the density of gold. So you have to know the basic formula for density. Density equals mass over volume. Right. So let's go for. Okay. So then D. And E, I think most people did pretty well on. It wasn't really the math section, so I'm not going to spend a lot of time on that. But D, describe two potential uses for mining waste. So you could say you could use it for construction, landfills, for new construction areas, to build dams, something like that. But you can't really say that it'd be used for topsoil, because most of this stuff is going to be all this dirt's going to be all mixed together. It's going to be called tailings. It's just topsoil and all this excess dirt just mixed together. So it's not really useful for that purpose, for topsoil, but you could use it for something else. And that's kind of what they want to get you to, right? Some kind of construction process, or making concrete, or you could sift through it to find other minerals, maybe rocks that could be used for landscaping. But you need to identify what you could find in there and what you could do with it. So uses, you can't just say, fill. You need to be specific about how it could be used. And then you had to describe two environmental problems that likely develop. So just what happens when people are done with mining. I mean, all this dirt, all this land is just exposed. It's not like anything's just going to start growing there. It takes a long time for topsoil to redevelop. So you could talk about topsoil depletion. And then, this place is probably covered with grass and trees at some point. So this was a habitat for somebody, or some plants at least. Even if it was just a prairie, there's, just grass growing on here at some point, and, a tree or two, that there were things there. And now there's not, and it would be a long time before that happens. So habitat destruction. You could also, some people talked about runoff. So now, as it rains, that all this dirt is going to run off. Where does it end up? It's going to end up in some stream somewhere, and if there's any toxic chemicals in that soil, guess what? Those toxic chemicals are in that soil. and are going to go downstream. So I hope that helps make some more sense of this. If not, let me know. When you set this up, this is for part A, and remember, always show your work. We have 7 of those blocks. The ones that have the most amount of gold in it, remember those blocks are 200 meters cubed. That's one block. And the concentration for that stuff is 2 times 10 to the negative 4th, but I'm not going to write that. I'm going to write 2 times 10 to the negative 6th. And I'll explain why that is. Remember, what we had was, for this concentration, it was 2 times 10 to the negative 4. But what I'm going to do is then divide it by 100, or in other words, divide it by 1 times 10 to the second, right? And so what that does is you subtract the exponents when you divide. So negative 4 minus a positive 2, right, is going to give you negative 6. So that's what I did. I just changed it from a percent to a real number, a decimal number, I should say. So what does this give us? Well, 7 times 2, right, it would be 14, and then add the 2 zeros, 1400. But we're going to try to multiply that by a number that's in scientific notation, so we need this one in scientific notation as well. So we'd move the decimal over 3 times, so it's actually 1.4 times 10 to the 3rd power. Right? I'm going to multiply those two numbers together. Remember, when you multiply them, you multiply the base numbers by each other. So 1.4 times 2 is 2.8, and then you add the exponents, so times 10, so negative 3 plus a negative, or 3 plus a negative 6 would be negative 3. Okay, so that's the concentration for the first part. Now the second, there's another part of it doesn't have any gold in it, so we're not going to focus on that. We're going to look at the next one. The next one, you have 6 of those blocks, same size, and the concentration for those is less, but it's 1 times 10, remember, to the negative 6th. So I'm changing that from a percent to a decimal number. That's kind of tricky of them, but you gotta remember what they're telling you. If it's percent and they're not asking for percent, you got to change it. So 6 times 2 is 12, and then add the 2 zeros, 1200. Change the scientific notation, 1, 2, 3. So it's 1.2 times 10 to the 3rd power. 1.2 times 10 to the 3rd power times 1, it would be 1.2. Add the exponents, 3 plus a negative 6 would be negative 3. And those are our only 2 sections. So now, if you add those 2 together, right, you're going to get 4 times 10 to the negative 3. Okay, and that's in cubic meters, and that would be your answer. Okay. Now there are other ways to do that. I mean, you could do all the percents times each other and then divide by 20, since there were 20, and that would give you the answer as well. Okay, so that's the answer, but let me just show you the other way, because I know some of you kind of wanted to look at this from a different perspective. So again, that'll work, but here's the other way. You could say, alright, well, we've got, for these blocks again, we've got 7 of them, without changing out of the percent, right? Because I know that can be confusing. So 7 of them at this like 2 times 10 to the negative 4th percent, right? And then there's 7 that don't have any, so we'll just ignore those. And then 6 that have 1 times 10 to the negative 4th percent. Okay? And we want to get that out of a percent, we're going to have to divide that by the total, which is 20 blocks. Okay? And if you do that, doing the math, what you're going to get what you're going to get here is 7 times 2 is 14, right? It'll be 14 times 10 to the negative 4, plus 6 times 1, 6 times 10 to the negative 4. So that's going to end up being, right, 20 times 10 to the negative 4 divided by 20. So what this ends up being is 1 times 10 to the negative 4, right? And that's percent gold. But again, right, because these are percentages. But we don't want percent, we want to get the amount. So what was the volume that we had? Well, there was 4,000, if you add them all up, cubic meters, right, times that percent. So this is like the total of everything, right, times that percent. You're kind of doing like a weighted average here. So times the concentration of that gold, which was this number right here, 1 times 10 to the negative 4, and you end up with your answer at 4 times 10 to the negative 3, right? And that's meters cubed. And see how these two numbers are equal to each other. They're the same thing. Right? So two different ways to arrive at the same answer. Whichever one works for you, review that one. Alright. Next, we need to look at what we had for B was to look at the percentages for each. So there's 7 blocks that had a concentration of 2 times 10 to the negative 4%, and then there were 6 blocks that had a concentration, right, so we're multiplying these together, 6 blocks had a concentration of 1 times 10 to the negative 4, okay, and divide that by our total, which is 20, and that will give us our percent, and what you get is what we had before, to 1 times 10 to the negative 4% gold, right? Now, of course, like I said before, there's 2 ways you can do this. The other way would be to take the amount that you calculated from before, that 4.0 times 10 to the negative 3 cubic meters of gold, and divide by the total to get, right, part over whole. The amount of dirt there is 4,000 cubic meters. So this is the amount of gold that there is divided by the amount of dirt that there is, and that will give you the percent, which again, if you multiply this by 100 after you get the answer, you'll get 1 times 10 to the negative 4%. Okay? That was not too tough, but it's just looking at percentages, and you had to do well in the first part to do that. So in part C, you need to find the mass of gold that you had from before. So you had this mass of 4 times 10 to the negative 3 cubic meters of gold, and that the density of gold, right? So you have 10 to the 6 centimeters. You're basically just converting from meters to centimeters, right? There's 1,000,000 centimeters in a cubic meter. That's a tough conversion to grasp, but that's what you need to do, because the cubic centimeters to grams is where you're going to, right? It's just because that there's 1,000 meters or 100 centimeters in a meter, right? So 100 centimeters equals 1 meter, but you're doing this in 3 dimensions. So it's basically 3 times that, right, in 3 different directions. So length times width, right, times height. So in each of those dimensions you're doing this. So you actually are 3 times 2 is 6 zeros, and that's why it's times 10 to the 6th up here. Tough one. But anyways, the meters of gold cancel out, centimeters cancels out, and it's grams. So it would just be multiplying these across with each other, and you end up with, for C, 76 right? 4 times 9 gives you the 76 number, and it's times 10 to the third grams, because it's -3 plus 6, which ends up as +3. But that's not scientific notation, so you got to break it down one more, so it'd be 7.6 times 10 to the 4th power grams. Okay, gold. And then that's how much gold how many grams of gold we're gonna get. But how much do we need per gram? Well, remember our total cost was that $1,520,000 that's gonna cost us. And if we have this 7.6 times 10 to the 4th grams of gold, that's going to tell us how much it needs to be per gram, right? So dollars over grams, right? How many dollars per gram does it have to cost us? So you're going to try to do this, but obviously it would be difficult the way it looks right now to try to do this. And what I would do is convert this to scientific notation. Right, so it'd be 1.52 times 10 to the 6th divided by 7.6 times 10 to the 4th. Right, and so what you can see here is if you rough this out, actually it works out really well. 1.52 divided by 7.6 is actually 2. Right, but if you couldn't see that right off the bat, you could do it like this, 1.52 divided by 7.6. Right? And if you do this times 2, just like say you're playing around, see how many times it will go in. 1 looks too small, maybe you can do it twice, so 2 times 6 is 12. 2 times 7 is 14, carry the 1 is 15. Right, it goes in there exactly 2 times. And then you, since you're dividing, you subtract the exponent, so it would be 2 times 10 to the 2nd power. Or actually 0.2 times 10 to the 2nd power, right, because there's a decimal here. And what is that number? Well, if we move that decimal over 2 times, that's 20. So what that means is gold has to be at least $20 per gram. It's so much you got to be able to get for it. Well, right now, I mean, this is just kind of an aside, it's not really part of the problem, but right now gold is at $45 per gram. So yeah, you're gonna not only carry that cost, but you're gonna make more than that on top of it, because this is twice as much as what it's going to cost you to do it. Okay, so not a bad deal.